start with visuals of deep space, nebulae, and distant galaxies. The tone is mysterious and awe-inspiring. Imagine for a moment that you're an astronomer, staring into the vast, silent expanse of space. You spend your nights scanning the cosmos, hoping to find something new, something that changes our understanding of the universe. Then, one day, you find it. A signal. Not just any signal, but one that repeats with clockwork precision. This isn't science fiction. This is the reality for astronomers right now. Deep in the heart of our Milky Way galaxy, about 15,000 light-years from Earth, something is sending out a radio signal, and it's doing it every 44 minutes. Like a cosmic lighthouse, it flashes on for a brief moment, then goes dark, only to repeat the cycle again and again. This isn't a random burst of energy, it's a pattern, a rhythm, and it has scientists completely baffled. The object, officially named GPM J1839-10, is unlike anything we have ever seen before. For years, we've known about pulsars and magnetars. These are super-dense, spinning remnants of dead stars that send out beams of radiation. Think of them as cosmic lighthouses. As they spin, their beams sweep across space, and if one happens to point towards Earth, our telescopes pick it up as a regular pulse. But here's the catch. According to everything we know about astrophysics, these objects shouldn't be able to pulse this slowly. There's something called the death line for pulsars. It's a theoretical limit. If a pulsar spins down and its rotation becomes too slow, its magnetic field should no longer be strong enough to generate the radio emissions we detect. The slowest known pulsar before this discovery had a period of about 23 minutes. GPM J1839-10 at 44 minutes is nearly double that. It's way, way beyond the death line. It's a ghost in the stellar graveyard, a star that should be silent, but is somehow still shouting into the void. So what could it be? The lead researcher, Dr. Natasha Hurley-Walker from the Curtin University node of the International Center for Radio Astronomy Research, and her team have been scratching their heads. They first detected this signal using the Murchison Wide Field Array telescope in Western Australia. Initially, they thought it might be a fluke, some kind of terrestrial interference, but they kept watching. The story gets even more fascinating when they decided to dig through archival data from other radio telescopes. They looked back through 30 years of observations from telescopes like the Very Large Array in the US and the Giant Meterwave Radio Telescope in India. And there it was, hiding in plain sight since at least 1988, the same signal, pulsing every 44 minutes. For over 3 decades, this cosmic metronome has been ticking away, and we've only just now noticed it. This longevity rules out many possibilities. Some cosmic events, like fast radio bursts, are incredibly powerful, but are usually one-off or sporadic. This object is persistent, stable, and predictable. The fact that it has been broadcasting for at least 33 years suggests it's a long-lived object, not a temporary phenomenon. The leading theory is that it might be a special kind of magnetar, what's known as an ultra-long period magnetar. Magnetars are a type of neutron star with incredibly powerful magnetic fields, quadrillions of times stronger than Earth ES. This immense magnetic field could be the key. Perhaps it's so powerful that it allows the star to continue producing radio waves even as its spin slows to a crawl, pushing the boundaries of the so-called death line. Think about the sheer power involved. For a signal to travel 15,000 light-years and still be detectable by our instruments, the source must be releasing an immense amount of energy. The pulses themselves are short, lasting anywhere from 30 to 300 seconds within that 44-minute cycle. But in that brief window, it shines brightly in the radio spectrum. This discovery forces us to reconsider our models of how neutron stars evolve and die. It suggests there might be a whole population of these ultra-slow objects out there that we've been missing because we simply weren't looking for them. Our surveys for pulsars are often designed to find things that pulse quickly, on the order of seconds or milliseconds. An object that blinks once every 44 minutes is easy to overlook. You might mistake it for background noise or a technical glitch. It's like we've been fishing with a net designed to catch minnows, and we just realized there might be giant, slow-moving whales swimming right past us. Now that astronomers know what to look for, they can re-examine old data and design new surveys specifically to hunt for these slow-pulsing oddities. Who knows how many more are out there waiting to be found? Each one could be a piece of the puzzle, helping us understand the extreme physics at play in the universe. Of course, whenever a strange, repeating signal comes from space, the alien question always pops up. Could it be an extraterrestrial beacon? While it's a tantalizing thought, scientists are pretty confident this is a natural phenomenon. The signal is broadcast across a very wide range of frequencies, which is typical for a natural source like a magnetar. An artificial signal designed for communication would likely be much more focused on a narrow band of frequencies to save energy and be more efficient. So, for now, the evidence points firmly towards a new type of star. But what a star! This is what makes science so exciting. Just when we think we have a solid grasp on the rules of the cosmos, the universe throws a curveball that shows us how much we still have to learn. GPM J1839-10 is a beautiful mystery, a whispered secret from a distant star that took 15,000 years to reach us. It's a reminder that space is filled with wonders we haven't even imagined yet. The team that found it is now scanning the skies, hoping to find another object like it. Finding more will help them confirm if this is indeed a new class of stellar object and allow them to study their properties in detail. Is their magnetic field really the key? How do they form? And how many are lurking in the dark, silently spinning in the graveyards of the Milky Way? The universe is under no obligation to make sense to us, but by patiently observing and questioning, we slowly peel back its layers. This 44-minute pulse is the latest clue in our grand cosmic detective story, and it's a big one. Thanks for joining me on this journey to the edge of our understanding. It's discoveries like this that keep me staring up at the night sky with wonder. What do you think is causing this mysterious signal? Let me know your theories in the comments below. If you enjoyed this video and want to stay updated on the latest cosmic mysteries, make sure to hit that like button and subscribe to the channel. Until next time, keep looking up.